Imagine you are driving at 100 kilometers per hour and you're about to crash the car. You would be safer in car 1, which has softer exterior materials, than in car 2. Here's why. Back then, passenger safety was a big concern. Car accidents were killing thousands of people every year, and the lack of safety features in vehicles made every crash potentially fatal. Many people worked very hard to make cars safer until one day an engineer from Mercedes-Benz came up with a great idea. In the 1950s, Bela Bareni, an important figure in car safety, introduced a smart idea called Crumple zones. His idea was to make parts of a car that could bend and absorb energy during a crash, making it safer for the people inside. His idea was based on two important principles in physics: momentum and impulse. Momentum is simply how hard it is to stop something that is moving. It depends on how fast and how heavy the object is. Imagine throwing two baseballs that weigh the same. If you throw baseball number 1 harder than baseball number 2, baseball number 1 is harder to stop because it has more speed. On the other hand, if you have two baseballs moving at the same speed, but one is heavier, the heavier one is harder to stop. So, momentum depends on mass, or in other words, how heavy something is, and velocity, how fast it's going. We can say momentum, we show it with letter P, equals mass time velocity. In an accident, a vehicle's momentum changes rapidly, and this change in momentum is called impulse. We can write it like this. I, for impulse, equals delta mv. We use delta to show change in something. So, impulse is the change in momentum. In this context, impulse refers to the force experienced by the passengers over a period of time. To understand this, let's use basic physics principles. We know that force is equal to mass times acceleration. Acceleration is simply put how much your velocity has changed in a fixed time. Therefore, we can write the right side of the equation like this: m times delta v divided by t. We multiply m by delta v, then we have F equals delta mv divided by t. We can also write it like this: delta mv equals F times t. Now, does delta mv look familiar? Well, we said earlier that delta mv equals impulse. Therefore, we can also say impulse equals F times t. In car accidents, the force experienced by passengers was a lot. Imagine like running directly into the wall. You will be stopped in a very short period of time. In that case, the time is very short, therefore the force is very large. Bela Bareni wanted to increase the time it takes to stop a car in a crash. He did this by creating crumple zones, which are parts of the car made with weaker materials. When a car with crumple zones crashes, these parts bend and increase the time it takes for the car to stop, making it safer and less violent for the passengers. In this case, the time is long, therefore the force is way smaller. This is the exact reason why parkour runners roll after a big jump. It's all about spreading a force over a longer period of time. Now you know exactly why soft car exteriors make it safer for you inside. But wait, what about Cybertruck with stainless steel and bulletproof exterior? Does it have a crumple zone? How does it work? Is it even safe for passengers? Click on the link in the description and join us in the community for free and find out.